To sketch the graph of this function, one of the easiest things to do is first of all to factor completely the two polynomials involved. So if we factor a 2 off, we're left with x squared plus 4x plus 3, and that factors x plus 3, x plus 1. Fairly easy factorization. In the denominator, we can factor an x off and get x minus 2. So from the factored form, we can immediately recognize the x-intercepts. The x-intercepts are where f of x equals 0, or in other words, when x is negative 3 and negative 1. So when x is negative 1 and x is negative 3, we have the x-axis intercepts. If we were to look for the y-axis intercept, we would evaluate at 0. But if I try and plug in 0, we get no solution. So 0 is not an intercept. However, x equals 0 is something special in this graph. If we look at the denominator, when x is either 0 or 2, the denominator is 0, which means there's the potential for this graph to have a vertical asymptote at either 0 and at 2. And in fact, as we'll see in a moment, we have vertical asymptotes both at x equals 2 and at x equals 0 along the y-axis. To examine those, well, first of all, let's look at the horizontal asymptote as well. To find the horizontal asymptote, I want to know what happens if x is very, very large, either in a negative or a positive sense. Well, if x is very, very large, positive or negative, these are the only two terms that really affect things. 8x plus 6 and negative 2x are relatively small compared to the x squared terms, so these two terms determine the behavior for large and small values of x, large positive and large negative. So if we notice this, the x squareds will cancel, so f of x equals 2, or in other words, the horizontal asymptote is at y equals 2. If x is very, very large, the y values are close to 2. So at y equals 2, this horizontal line, we will have a horizontal asymptote. Now, to examine the vertical asymptotes more carefully, I need to ask the question, what happens to f of x if x is close to 0 both on the left and on the right? So let's say x is getting close to 0 through negative values of x. In other words, x is close to 0 and negative. So we're thinking about x is very close to the origin, but on the left side. So if x is close to 0 on the left, let's look at what happens in the numerator. If x is close to 0, 2 is still 2. If x is close to 0, x plus 3 is close to 3, and x plus 1 is close to 1. In the bottom, if x is close to 0 but negative, I'll put down a 0 for this factor, and I'll put a little minus sign there to indicate that it's close to 0 but negative. X minus 2 is close to negative 2. So if we look at this expression, it's not really a numerical expression, but just an indication of what's happening. If x is near 0, but on the left side of 0, the top is close to 6. The bottom is close to 0, but it's going to be positive because I have a negative number times a negative number. So this says we have positive infinity, which means that as x approaches 0 from the left, y gets very, very large in a positive sense. So we have an asymptote up there. Similarly, if x is close to 0 on the other side, the function goes to negative infinity. So we have this behavior, on this side. And if we do a thorough analysis for the rest, what this function must do is come up and back down again. Doing that same sort of analysis, we get this part of the graph. Now, since this is an asymptote and those are intercepts, this function actually drops below the axis, comes up, and does this from the bottom side.